Welcome to this part 2 of this particular tutorial. We had started looking at Cambridge Physics, Igcse paper 0625, that is paper 4. So we were looking at structured questions and how to approach each of them so that you can be able to maximize on the marks in this kind of paper. So the topic was thermophysics, thermal processes, whereby we're going to talk about heat and thermal energy transfers. So these are the areas that we covered in the previous tutorial. If you have not watched, just check out so that you can be able to see what we discussed in this area. So we are going to pick from question number 9, and number 9 says a beaker containing some water at room temperature. The student places mercury in glass thermometer in the water with the bulb of the thermometer just beneath the surface of the water. So we are told the diagram shows the arrangement, how this is actually done. We are told that the student places the thermometer near the bottom of the beaker, and electric fan continues to blow across the top of this surface. So which means that we are having a fan that is going to actually rotate. So as this fan is going to spin round, it means it's going to blow the air around the surface of this water. So which means the temperature of the top surface will cool down. There will be cooling taking place. So this water will become cold at the top. So immediately the water becomes cool, it contracts, it becomes less dense. Then that cool water will sink down, warm water will rise up. Yeah, so we're going to have water here will cool down, then cold water will move down because it becomes less dense, and then we shall have warm water rising up. This is warm water. Yeah, so basically that's what will happen, because state the name of thermal transfer method causing this and explain what happens. Yeah, what happens. So in that way we are going to say as the fan blows, at the surface, water at the surface cools down. And when water cools down, we have said that water will become less dense. Becomes more dense. I need to be very clear on that. When water cools down, it becomes more dense, and then sink. Warm water rises up to replace the cold water. This continues setting up convection current. So this continues, and eventually we shall have convection currents. Water is going to, and thermal energy is transferred by convection. By convection. Yeah, so that is the processes that takes place, especially in this particular question. Question number 10, we are told the diagram shows cold plastic spoon that has been placed in a hot liquid in a cup. Describe in terms of molecules why temperature of the whole spoon increases. So how is temperature in this whole spoon increases, yet it's just placed inside a hot liquid? So what happens is that when So in this question, we are told that the diagram shows cold plastic spoon, which is placed in a hot liquid. We are supposed to describe in terms of molecules why the temperature of the whole spoon increases. So we are going to look at this as molecules of the hot liquid. Yeah. Molecules of the hot liquid will collide with the molecules of the spoon. So which means that now the kinetic energy of the molecules of the spoon will also increase. These molecules which are next here, as they collide, they will also collide with the neighboring atoms or the neighboring molecules of the spoon also, which means now thermal energy will be transferred to the rest of the spoon. So we are going to say molecule of the hot liquid collides with the molecules of the spoon. Making the molecules of the spoon vibrate faster, yeah, which also collide with neighboring molecules. Causing the temperature of the whole spoon to increase. Yeah, so what happens is that the molecules of the hot liquid have high kinetic energy because it's hot, so it's going to collide with the molecules of the spoon, increasing the kinetic energy of the molecules of the spoon. Now the molecules which are next to the liquid, the molecules of the spoon which are next to the liquid, as they collide, they also collide with the molecules, the neighboring molecules. That increase in the vibration and the collision is the one that results in an increase in temperature of the entire spoon. So moving to still part B of this particular questions. describe additional process by which the temperature, in part B of this question, we are expected to describe additional process by which the temperature of the whole spoon increases. And in this one, we are going to focus on the free or delocalized electrons. So we are going to say molecules of the hot liquids, molecules of the hot liquid transfers energy, that is thermal energy, to the free electrons. Yeah, transfers the energy to the free electrons, because if we are talking about a metal structure, in a metal structure there are always electrons which are free to move all along. So those free electrons are the ones that are going to acquire the energy from the hot water. Yeah, the free electrons of the spoon. So the free electrons of the spoon will acquire, and they move. We are talking about the free electrons move through the metal. Electrons move through the metal, transferring energy. So this is, in simple terms, what's happening. This spoon that we are having here has got what we call free electrons, and these free electrons are free to move from one point to another, from point A to point B. So the moment this liquid transfer thermal energy, the free electrons will be able to move, will be able to have high kinetic energy. So they will be able to move from one end to another. In the process, as they are moving, that's going to transfer thermal energy. And if you are holding this spoon here, you will feel some heat, and you can be able to drop it if it's more hotter. Yeah, so basically that's what we are supposed to mention. But part A, when we are talking about molecules of the structure, if the temperature is high in the water, it will make the molecules of the spoon to vibrate. As the molecules of the spoon vibrate, they make the neighboring molecules also vibrate, and in that process, temperature is, or heat is transferred. Explain why houses in hot countries are often painted white. Use idea about transfer of thermal energy in your answer. Mostly houses in hotter regions, we can talk of Qatar, they are mostly painted black. Sorry, they are painted white. What's happening? They are painted white so that they can be able to reflect radiations away, because white and bright surfaces are good reflectors of heat. So we don't want the house to absorb a lot of heat because it's already hot. So the reason is, this is to reflect radiations away so that the house can remain cool. Yeah, the house can remain cool, and this is due to the fact that white surfaces are good reflectors of thermal radiation. Yeah, so basically that's what, in a nutshell, that's what you are to mention. So in this question, you are not going to write word by word as I'm writing. Ensure that you include the keywords, reflect the radiation, the house to remain cool, and white surfaces are good reflectors. Those are the keywords that you'll never miss, in that particular question. Moving to question 12, we are told that a star approaches the end of its life because we know during the evolution we know during the topic, we talked about the topic of space physics. Under space physics, you are going to learn about evolution of stars, because stars evolve from one stage to another. Stars start as a protostar, they became main sequence, they became the red giant or red supergiant. Finally, that star may become a supernova if it was a massive star, and then a neutron star. Later, if it was a less massive star, it will become a white dwarf, isn't it? So during the evolution of a star, the star cools down. State the effect on the rate of emission when it cools down. We're going to say the rate of emission, the rate of emission will be lower or will decrease because the star will be less hot. So the rate at which energy is emitted from it will be less. Then state the benefit of firefighters. We are done with this question, so we can move to the next one. Yeah, can move to the next one. So sorry, what's this? All right, so I think it's taking long to. Now the diagram shows firefighter wearing shiny silvered colored clothing. This guy is the one that comes to put off the fire, and then we are told these people usually they put on shiny colored clothing. What is the reason? What is the benefit for that? Yeah, this is to keep the firefighter cool or cold. Yeah, because this person is exposed to a lot of radiations, fire. Then if he's putting on black coat or black jacket, it's a good absorber. Black surfaces are good absorbers of heat. So this person will be absorbing a lot of heat, and then he is going to experience a lot of high temperatures. But if putting on silvered colored white clothes, it means that this person is going to reflect the radiation. Radiations will be reflected away from his cloth. So meaning he will remain cool. Yeah, so we were supposed to just state the benefits, and that is exactly the reason we're going to say, so that it does not become too hot, it's not burnt from the radiation, or we can say not to be burnt from the radiations. So if the examiner is going to misbehave and ask you explain why that is the case, you are going to say white and bright surfaces or silvered surfaces are good reflectors. They reflect the radiations away. Right, so can move to the next question, and the next question here is quite interesting. And then we are told about during a picnic. So in this particular question number 14, we are supposed to explain how electron transfer thermal energy through the metal can. So we know that the atoms of the metal can vibrate. As the atoms of the metal can vibrate, they are going to hit the free electrons, making them to move to the far end of the metal can, in the process transferring thermal energy. So that's going to say, as the atoms of the metal can vibrates, it hits, or they hit the free electrons, they hit the free electrons, making them to move or to travel. Yeah, they make them to move or travel to the other parts of the metal can, transferring thermal energy. Yeah, so basically that's what we are going to say at this point. So we shall look at this remaining part of the question in the next series, that is part 3 of this particular tutorial.